review number 2. This is not the, hold on. Yeah, this is probably the way to set this up. So, again, grade yourself. Like if you're missing something, feel free to ask a question and I'll tell you how I would have graded it. Because I don't want you feeling like you have to be exactly like me, but this is a pretty good idea of what the topics you're going to need to mention. You don't technically have, nobody's going to give you a picture or a point for a picture. I used to do that, but I don't do that anymore because AP doesn't do that if you were to see a problem like this. But it says we're maximizing volume, so there's my volume equation. It says we're cutting corners out of this box. We've done a number of these already. It said the box originated as a 7 by 12 piece of cardboard. And if I cut these corners out, then the inside length and width will be not 7 minus x, but 7 minus 2x, 12 minus 2x, and then the height as you fold those x's up would be an x. And then you're going to get 3 points for that, maybe 2 from AP, but I might give you 3. And then you're spitting out the whole scenario again. The derivative of v is 0 at that x value. I also noticed that the derivative went from positive to negative here, therefore maximizing the volume. I put is maximized. I should have said v is maximized. Therefore, v is maximized. And then answer the question, which is what is the maximum volume? So the volume. And if I'm typing that in my calculator, if I have an 84, this was saved. So I would have just gone back and just done y1 of x. Don't ever write that on your test because AP is going to go, what the heck is that? Say the volume is this. Also, don't say volume is 54. You could, but it's better to say the volume at that, or to say the maximum volume is. But state what you're doing because the volume could vary depending on the x value. Again, be as clear as you possibly can when you're speaking about all this. And then if you had it inspire, of course we don't have y1s, we have f1, but you would have had to store that value. I usually use a. You would have had to type that in your calculator. And it just saves you the trouble of having to type in your x 3 times. And if you use a rounded value there, and there, your answer could become a little off. And sometimes it's a matter of a hundredths place the answers. And you really want to be exact. And if you're off on a free response one and you're not right to either a truncated or rounded 3 decimals, and remember what that is? Truncated is just chop it after the third, and rounded is round the third correctly. Either one is fine with me, but that's where you get your last point. And then I wouldn't count off for units cubed. The only time I count off for units is if I've given you the units. If there are no units mentioned, nobody seems to care. All right, so that might have been a 7-pointer. Number 2, I don't remember doing one like this in class, so let's talk about it. Also, I am not going to make you know areas like surface area of a sphere or that kind of stuff. I will give you those at the bottom like I did on this quiz. So stuff like surface area of a sphere, volume of a sphere, volume of a cone, that kind of stuff is not needed. Although you might be given extra equations, like I believe I gave you extra ones there. But anyway, but you do need to have to know stuff like the volume of any shape if it has a consistent cross-section. Like if your cross-section is always the same thing, then the volume is the area of the cross-section times the height, or times the length. It was like that way. That's something you should know. Area of a circle, area of a rectangle, area of a triangle. Those basic things that you should know, they're going to hold you accountable for that. So on this one, it says a solid's formed by putting 2 hemispheres at the ends of a right circular cylinder. The total volume of the solid is 12 cubic centimeters. And it says find the radius of the cylinder. So find R that produces the minimum surface area. So I'm minimizing my surface area. So I want the surface area of what 2 things? The sphere, and it's not really a hemisphere, is it? Because it's a hemisphere on 2 ends, which makes a sphere. Now, if it was just a hemisphere, like if it's just that, then make sure you take a half of that. But in this case, it was just a sphere. I gave you that was 4 pi r squared. So that is your sphere's surface area. And then how do I find the surface area of a cylinder, like a toilet paper roll?
2 pi RH.
2 pi RH gives me the circumference, because if I were to take this thing and cut it right there, the cylinder part, and open it up, it makes a rectangle, right? So the 2 pi RH is the length of that rectangle before it's connected, and then you want the height. So 2 pi RH, 2 pi R times H. And then I have this thing up here, and I have too many variables that don't match, so I replaced the H and I used the volume equation for that. So I knew volume was 12, but what's the volume of this whole thing? Well, you got a volume of a what? Sphere, and I would give you that, and I did in that formula, so that's a 4/3 pi r cubed. So there's the volume of the sphere, and then that is the volume of the cylinder. Remember, we said if you had a cross section, which you do, right? Pi r squared is the center. is the area of that, and it's consistently that all the way around, and then times height. And there's the H I need to solve for. So I'm going to solve for H there by, and I didn't cancel that B, I replaced it with the 12. I'm going to subtract that to the other side and divide by a pi r squared. And you don't have to do any simplifying, because all of that's going in for H. I see people all the time on this test. Every year I give a question like that, which I don't every year, but if I do, they come in there and they start canceling R's and pi's. If you do it correctly, great. But if you do it incorrectly, well, then you just missed this problem. Everything else mathematical about this problem, you're going to be wrong on. Yeah?
To plug it into my calculator, I had to cancel the pi and r for it to be able to work. It just gave me an
Did you
error.
put a times right here?
Just a possibility.
Yeah, if you put a times, I don't know why it does that, and it's really annoying that it does, but if you put times in there, it usually lets you do it. But for some reason, when you don't, and it's really annoying about this Inspire, because the 84, which is 30-year-old technology, oh, I thought it only went back to a TI-82. I found a TI-81.
What about a TI-1?
I don't know about that. But I have one. I don't know if it's still, I have it back there. It's a TI-81, but it's missing the little, it comes with it needs triple A's, but it also has a little chip battery. So I'm going to see if I can fire it up and get a little chip battery. But Welly found it in his classroom somewhere. And he goes, he goes, I got a calculator for you. And I'm like, oh, sweet, a good kit. And I'm like, oh my gosh, this is an antique.
It's somehow old.
And it's really old. I didn't even know they made 81s.
He was a professional architect.
Yeah, he found it in Tunisia.
What?
They dug it up at a site. I don't know. It's really old. Yes.
So I did it the other day where I canceled it out. I separated the fraction and canceled it out, and I got the wrong answer, and I just plugged that in, your A. I just plugged it in, and I still got the wrong answer for homework.
It's tough.
And
Did you get
I can look at what you're doing.
I got 1.109.
Yeah.
Oh yeah, I got that too.
I got what you got.
Did you get what I got?
Yeah, I got what you
I got what you got.
I can look at what you have typed in and see if there's an algebra error or maybe a typo or something like that. Do you want me to look at it later?
Yeah, no, I'm pretty sure it's for the 4 pi r cubed. I put 4 pi r square. I remember now.
That's the one.
Oh, you put a cube in there too? I got you.
Oh.
Yeah.
Yeah. So be careful, it's usually something small. Now, that being said, had that happened on a test, like if you had 4 pi r cubed, I'd have been like, And I might have given you a half a point there, and if everything else was right,
No,
I don't know.
when I plugged in the calculator for the part of it that's 4/3 pi r cubed, I put a
In the
4/3 pi r
parentheses, you
square.
put a
Oh,
square.
okay.
Because, the button for square is so easy.
Right. Yeah, be really careful entering your stuff. And of course, if you show me your work, I'm gonna try to give you as much as I can, because I do recognize that these problems do. You make one little error here, and then this is gonna be off technically, and that would be right, but that's gonna be off. That would be right, but that's gonna be off.
Oh no.
But you wanna, I will look at it obviously and do the best I can with it. I don't wanna just crush you on everything, but I have built a 4-point scale into this to hopefully help with maybe 1 or 2 of these little errors. But ultimately, if you know what you're talking about, you'll still be okay. Yes?
So how many of these questions, is the test just going to be like just a series of these questions?
Yeah, well, and tangent line approximation.
Oh, yeah.
So, like,
Don't forget to study that. Every year people forget to study
I
that,
totally forgot.
and then they're like, oh crap.
So it's all stuff between the first and second quiz, there's nothing like else thrown in there.
No, it's just, expect to see a bunch of these that we've talked about. It's a doable number. I put a bonus on there too. There's a doable number of problems on there. So like when the bell rings, if nobody's moving, don't go, oh, that was way too long. I doubt it. I've used similar questions before in the same quantities. A lot of people are just working on the bonus question. So that is possibly what happened. But don't forget to study tangent line approximation. And I'm going to give you the first page of it is going to be non-calculator. So you're going to have to work one of these without a calculator. Okay? Just one. It's not going to be, I literally have picked one that's not brutal algebra, but the major difference is when you solve manually, you're getting this value, but you can't just say, hey, it went from negative to positive unless you show me a check. Now in the AP test you could, because they don't look at your number line analysis, right? They're told not to look at that, but I do because I'm checking your knowledge of how you figured that out. But on the AP test, you would do that just for your security, and so you would know because you don't have a graph to look at like you do on a calculator problem. Are y'all seeing that?
See ya.
Okay, so moving on from that. There's another margin problem. And on these margin problems, remember there's a couple of different ways you can do it. I chose to call this X and that Y so that the area of my whole page was X plus the 2. And hey, every year people go and label this and they write X plus 3, Y plus 2. Or I'm sorry, Y plus 4. And they get the numbers wrong. Remember, if the sides are 2, then the sides are 2, right? Make sure that when you label this, you're going X 2, 2, X plus 4. And then if the height, the margins on the top and the bottom are 1.5, then it's Y. That margin is 1.5, the margin is 1.5. Whatever that variable is plus 3. And I don't care whether you use X and Y. If I care, I'll give you the picture and I'll label it myself. And then because the printable space is 100, 100 equals the X times Y, so X is 100, or Y is 100 over X, plug 100 over X in there. That's one option. But you are totally fine to call this X and this Y. But in this case, your area would be that. And if that's the case, what would this part in here be? It'd be an X minus 4. Does anybody tend to do it this way?
No.
Nobody? You do?
Oh, I
So
didn't
you would
know.
have an X minus 4, and you'd have a Y minus 3, and you'd have to go, oh, well, 100 is X minus 4, Y minus 3. So you divide by that X minus 4, and add a 3 to solve for Y, and that would go in here. So your area equation would definitely look a little different, and the value you get for X is probably going to be different than mine. I mean, not probably, definitely going to be different than mine, but that's okay because in the end, whatever you find for your base, like I'm going to calculate base by going X plus 4. Your X that your calculator spit out would be 15.547. I'm guessing, depending on how you label it. And then my height I found by going Y plus 3 or that plus 3. Your height would just be, would be this thing. 100 over X minus 4 plus 3, which is a little different. But in the end, your answers will be the same, but all the work in between there is going to look different. And that's totally fine.
Firstly, it should be easier if you were doing it not using the calculator, because you wouldn't necessarily have to calculate a fraction, or you wouldn't have to deal with many fractions when you're doing the calculator.
Yeah, I don't know. I don't know what. I don't know which one would be easier, honestly. In this particular one, because the X values are so bad, I don't even know if you'd be able to do it. It's possible that that's like something a lot more similar, simple than it looks. Like 25 divided by root 2 or something like that. It just looks ugly. And if you had been doing it manually, you run, oh, okay, that's just a value I can use. I can approximate what that is. I don't know. But I have looked at the one that was the non-calculator one, and it was pretty doable. And like, for instance, if you'd set it up like this, and I was gonna take the derivative, I probably would have multiplied it out first. 100 plus 3x plus 400 over x plus 12, and I would have said, all right, take the derivative of this, and that goes away, that becomes a 3, that becomes a low d high, which is 0, minus high d low, which is 1, over low squared, derivative that's 0, and I would set that equal to 0. I can solve that. I mean, it may look a little ugly, but look, this is the kind of thing that it's not that bad, and I could probably do a couple of tweaks to make the algebra work out a little bit better. So if you take x is whatever that is, remember it's only the positive version, and that's what, if you do the math on it? It's a 20, right? Because the square root of that is a 20, square root of that is, I'm not sure, but if you were to do the math on this, actually it might be easier to think like this. This is like about what? Root 3 is about 1.7. What's 1.7 times 20? Like 34-ish over 3. 11-ish, right? So if I'm checking a number line analysis, and that's about 11, and I'm not still 100% sure that it's 11-ish, I'd probably check maybe the area at, or the derivative of the area maybe at 10, maybe the derivative of the area at 13. Just pick some numbers that are clearly on either side of it to figure out where I'm going to maximize that volume. And if I check values like that, you'll see it's maximized there and blah, blah, blah.
Will it like work?
Actually,
like
I'm
that?
trying to minimize.
Yeah.
Are you gonna throw any triplets in there where the critical number isn't the max? Or
It's possible. It's possible. I know I have one in there that checks your knowledge of your calculator.
What do you mean by knowledge of the calculator?
But I think I even made it a bonus.
What's its name?
There's a little thing that your calculator, you'll see it. Just don't freak out, right? When you see it, you're gonna go, what the heck?
I need to read the name.
Now, it's possible you go, what the heck, because you screwed up. But if you're doing a problem and you suddenly go, what? I'm just giving you a little hint. There's something on there that I want to see.
One of those weird guys' names where nothing worked out the way it was supposed to. No, it was like what were their names? It was like Luminance, or no. It was one of these.
Galaxy?
Yeah.
Oh.
Oh,
Close.
that was a great book. We wanted to adopt it, but there's just a book called, it was Rogowski and something, but it was a really good book. And
Rogowski and Larson.
yeah. Well, the Rogowski, I think we have the,
Those ones were weird.
no, we have the Stewart, yeah. Larson, yeah, that book was actually a really good book and much smaller than this giant one you have. Although we did order a really nice small version of yours, and a giant one came in by mistake. And before we could send them back, somebody comes in there, stamps it all with Homewood High School. We're like, oh my gosh. So we're stuck with them for 12 years. They weigh like 6 pounds. Anyway, whatever. And then the last one, again, we've seen problems like this before. There's a rectangle. We've seen exactly this problem, except maybe that 25 was changed. But again, if I'm finding maximum area is not x, y, it's 2x times y. And the y, well, oh my gosh, look at that. Because the y is just the y coordinate of any point on this circle. So I make a substitution for the height there, and then I'm going about my business.
How did you know to call half of the rectangle x instead of the whole one? Because I did that and I just got 12.5.
Right, it's because I'm dealing with this. If I want to incorporate a graph is on a coordinate plane, right? So any length is always going to be measured from here. Like if it's a point on the curve, it's really a better question than you think. If it's a point on because a lot of people do that. They just label stuff x without, but I have to make it fit this narrative. So this length is always measuring it from the origin. So if I'm going to ever do anything with an x and y, I have to think about how X and Y operates. If I didn't have a coordinate plane on here, and I just said something like, hey, this is the height function. Now, I still would want to be careful, because if that's the height function, I would want to know, what is X? X is that length on this function that is always measured from here. So technically there's two of them. Right? But if I had a height function that was just based on the base, if there was some height function that said, hey, whatever base you pick, blah, 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 plug it in here, well, then I can just call that B or the whole thing X. But my height is based on a movement from the origin, right? That X movement, so I have to double it for the whole width. All right, y'all track with me?
Tracking.
All right, I don't like to have a review sheet, because I know how review sheets work. I give you a review sheet, it's got 6 problems, everybody studies those 6 problems. And I want you to know how to do everything that we've done, homework, review, whatever. John?
On the last problem, at least for the scoring, do we have to write like maximize, or can we just put the time goes from positive to negative? And also, do we have to do the domain?
Well, what are you telling me when you say A prime goes from positive to negative? I want to know what you mean by that. Okay, it goes from plus to minus. So you want to tell me, hey, the area is maximized. That's you're basically doing one of your tests. A derivative is going to be a max or a relative max when it goes from plus to minus, when a derivative goes from plus to minus through a 0. So that's literally your first derivative test. So you're stating what that means. And then again, you can say maximum area is that, or you can say A of that is that. But don't just go, area is 25, and I'm going to go, what do you mean area is 25? Area can be lots of things. It's the area at that X value, or the maximum area that's 25. And then again, it didn't mention what the unit actually was, so it's not super important that you put unit squared, but anyway, certainly wouldn't be taken off for that. All right, how about, trying to pick something that we haven't done today. Look on, I want to say it's maybe page 29. Have you all seen this one before? It's number 2. All right, so number 2 says you got this physical fitness room that's got a rectangle with a semicircle on each end. So some kind of rectangle, semicircle on each end. So you've got some track, evidently, a 200-meter running track runs along the outside of this room. So I know that the entire perimeter, the entire outside perimeter is 21. I'm sorry, it's 200 meters. It says draw a figure, I've got that, use X and Y to label the length and width section. That is going to be completely up to you. I'll probably just call, I know the radius is going to have to be involved in this, so I'm going to call the radius X. So that would be an X, that would be an X, right? And then I know that this length right here, I guess I can call Y, just for lack of knowledge at this point. But since I know the X is going to remain in there, I'm going to label that. And it says write the area as a function of X. So I want the area of this whole thing. What would the area of this be?
2xy plus pi
So
squared.
2x times y gives me the area of the rectangle part. And then the area of the circle part would be pi r squared, since there were 2 halves. Pi r squared. And Ray said radius was x, so pi x squared. But I still got a y in there, right? So I certainly want to get rid of that. And I should be able to with perimeter. If perimeter is 200, what is my perimeter equation?
2y plus
2y plus,
pi 2x.
so 2 pi x, because that's the circumference of the circle. So 2y plus 2 pi x, and we already know perimeter is 200. So that should be pretty easy to solve for y. And listen, we're not, I mean, if you want to divide a 2 out, divide a 2 out. It's not rocket science in this spot. Just make sure you don't cancel that and just go 100 minus 2 pi x, right? I can cancel that 2 out, but I get 100 minus pi x over 1. So there are times when I just want to save myself a couple of button pushes. Fine, but you don't have to if it's a calculator problem. So that's going in here. And if I were guessing, you'd probably get a point for that, a point for that, and a point for that substitution.
Is this a calculator problem?
Just eyeballing it.
Yeah,
It does say calculator. Oh, yeah. I really think you could probably do it without one.
What does it say on problem two?
Well, for part C, it says use calculator.
Let's read.
Oh, yeah, okay, so part C says use calculus to find it.
No.
Now you'll see, it's not as bad as it looks. Now, guys, I want to clean it up, so I'm going to distribute that in and get 200x minus 2 pi x squared plus pi x squared. Well, I actually have like terms there, don't I? So 200x what? What's negative 2 pi x squared plus 1 pi x squared? Negative pi x squared. And I'm going to take the derivative. Actually, I haven't taken the derivative of anything yet, sorry. I'm going to take the derivative of that, which gives me 200 minus 2 pi x, and set it equal to 0. And you're going to see this is not a big deal to solve. You just have to use some common sense here. So I get 100 over pi. Now, if you're not sure, 100 over pi, which is like 3.1 something, right, is rough. Did I make a mistake?
Can you cancel out that x there when you need to just move it up to the side because then 0 is also a critical number?
What?
Like with the 200x minus pi x squared. Oh, never mind.
If I was solving for that, I would.
Yeah.
Yeah, but I took the derivative. So right there, what's 100 divided by pi? If it were me, I probably wouldn't be dividing 3.414 in there approximately to figure that out. It's about what? I'm guessing probably 33, 34, whatever. So if I'm thinking about that to check that, then what would be a safe bet to check over here? Yeah, definitely 30, because that goes into 330 something. So I maybe check 30 and then maybe check, I don't know, check 40. I mean, whatever. Just pick a couple values that are in there. But if I check 30 in there, I get 2 times pi is 6.28 times 30. Feels less than that. Actually, it's positive. If I plug up, but if you're not sure, if you're not comfortable with that, plug a 20. That's 6.28 times 20, right? Definitely positive when I subtract it from 300, right? And if I plug a 40 in there, 6.28 times 40, definitely over 200. So when I subtract them, negative. Again, pick numbers that you're happy about. You can pick anything that's smaller, bigger. You don't have to be like right on either side. We did that only out of convenience. So that would be enough to see, for me to know that you checked it and you know what you're doing. But I still want to say the same stuff. I want to say a prime equals 0 at x equals 100 over pi, and a is maximized here because the derivative goes plus 2 minus. And then answer the question. And I could use calculus to find the same thing. The only difference, if I was using calculus, everything I circle in purple wouldn't be here. Like all of this right here wouldn't be here. I would have a equals that, then I would say the derivative is 0. Actually, I wouldn't need any of that, right? because I've already said that again. All that would be gone, I would have an equation, the derivative is 0 at x equals, except this would be some decimal that I found, and then I would state, oh, I looked at the graph, and the derivative graph went from plus to minus there, and then all I would have to do is answer the question, which is what?
The area.
Did I even ask a question?
Yeah.
Yeah, it was
Just verify the
not really clear until I-
and verify the maximum area for the graph.
Okay, verify the maximum area, so I would come back and say, yeah, it's not very clear, they're more clear on your test.
Jesus.
So max area
It
is,
just ends up being a circle.
oh, yeah, you're right. Yeah, the y ends up being 0. Sometimes, by the way, your calculator may lie to you on that 0, but hopefully you can figure that out. Like, have you ever seen, like, you graph a 0, you find it and it goes, it'll say y, it'll say it's a 0, and it'll give you the x value, and the y value will be like 6.2 times 10e negative 47. What does 10e negative 47 mean?
0.
It means times 10 to the negative 47th power, that's what e means, times 10 to the, so if you ever see that, that means the calculator's wigging out a little bit, but it's a lot of zeros. If you're rounding, definitely it's 0. So every now and then it'll do stuff like that. But anybody get an answer for this? Anybody? No? Or what is- Yep,
Can you answer a question like on a problem that's not on the sheet?
sure.
I was wanting to do on the Rogowski and Larson.
Can you give me a page number?
Yeah, 19. And then it's the third problem. I just want to see like what happens on the calculator.
That maximum surface area? Oh, what maximizes what's strange about this, larger possible surface area, there isn't one. So when you went to graph it, if you found if you found a critical number, it wasn't going, the derivative wasn't going plus to minus, it was going minus to plus. So what that means is, if that's a relative min there, then where would your max occur? At the endpoints, possibly, if there were any. But then you go back at this and you're like, well, is there an endpoint? Well, think about it. If I told you I wanted to get 16 ounces into this can, now we all know, well maybe we don't know, but you gotta figure some physicists have been called in, or some economists have been called in, and somebody over time has figured that this shape of this can is the best, most feasible, cost-efficient way to give you a can of food, right? You notice that you don't see a lot of cans that have lids that are this big, like a pothole, and that are like a ½ inch thick. I mean, just the cussing from the mothers, with the cranking their can openers, whatever, and then scraping out a ½ inch of food. It doesn't make any sense. But it would be a massive waste, right? But in theory, couldn't I just make bigger and bigger lids and smaller and smaller and smaller and smaller heights? Until some point we had a height that was like an infinite amount small, but an infinite big lid. We couldn't even fit in our can or our car. So in theory, there is no minimum surface area, or no maximum surface area of a can, because I could infinitely grow. And if you look at the equation, you can see there is really no domain on that. Now, if you're asking, and the real question is that going to show up? I mean, I'm not going to make it show up on a 9-point question where you just get obliterated, but that concept might pop up where you're like, oh, that makes sense, because there really is no, it's like some equations. Remember this equation you used to deal with? Remember that? And as one gets smaller, the other gets bigger. As one gets bigger, the other gets smaller. Well, you saw that on the graph of it, right? On the graph of it, yeah, as x gets bigger, y gets smaller, but there never was a min. And as x gets smaller, y gets bigger. There never was a max. They both approached infinity or 0. So it's kind of hard to determine what the max is. You have to go forever, and that's what's happening here. And if you look at your equations, a lot of times it will resemble that in some ways, even though it'll be ugly looking. It'll have that same kind of behavior. Yep.
How, on the AP test, if we're asked something like this, how would we go about answering that to the fullest pointage?
I gotta be totally honest with you about the AP test. This used to be a very typical 9-point free response question. back in the 70s and the 80s before calculators came along. And then when calculators came along, people are like, you know what, there's so many other things we want to ask. These just started fading away. So most of the time now when you see a problem like this, if it even does show up on the free response, it's 3 points. And it's usually not overly tough. And if it shows up on multiple choice, it's a 1.2 point question. 1.2 points is what you get for the, I don't know why they do, but that's what they're worth. 1.2. And then it doesn't matter what work you show. But it does show up 2 years ago, not last year, but 2 years ago, it showed up for like, I want to say a 3-4 point question on a free response question.
So like optimization or just that one? Like
No, not this. Is that what you're talking about specifically, this kind of question?
Yes.
Honestly, if that kind of showed up, it might be a question where they find the area, and then a little sub-question like, oh, what would happen, blah, 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 and it's 1 point.
Alright, so is optimization just not show up a lot?
No, not much anymore. If you get 2 to 5 points, you're gonna get a couple points out of it. So you're gonna have to know how to do maybe a couple points, and the whole idea of optimization shows up a ton, like from the standpoint of finding where something is maximized, right? That you see that's the first derivative test. We're doing that over and over and over again all year. We're gonna do related rates next chapter. You're gonna be seeing it some more. So that first derivative test shows up all the time, but a straight up optimization problem, not as much. But in college calculus, they can spend 2 weeks on doing this kind of stuff. They love optimization because it's a real life kind of situation. And I mean, a lot of the ones we're doing aren't real life, but some of them you can actually think about, how do I make a silo that maximizes this? Or how do I do so-and-so? And so that actually does, how do I make a box that minimizes waste or maximizes volume? Those kind of questions are really prominent questions of the day, although it's probably taken to a different level. Because nowadays you've got stuff like, well, if I just make a simple box that I have to glue, there's time involved and I want to cut time. So I don't know, again, I think I mentioned this before, but if you ever go in some of these shoe boxes, the way they take a box and stamp it, like just make a cutout, and then you pop a couple pieces here and you fold it a certain way and it all gets together and it's shockingly held together. No glue, none of that stuff involved. So you can have, and then you have some guy like, you've seen that guy on the Domino's commercial, the world's fastest box folder. He's like, and you have guys sitting there folding these things, or maybe even machines doing it. But again, it's all time and money, trying to minimize the time, minimize the cost, minimize the waste. So this guy's thinking that stuff up using calculus very often.
I don't think I've seen that commercial.
Have you not?
I've seen it.
It's just a guy folding boxes really fast.
And he can whip it out. I mean, he is really fast. Like, he can fold a pizza box. With like, 2 seconds.
Yeah, all the stacks up
Yeah.
behind him.
Yeah. So, anyway, but yeah, calculus 1. Should you have to take it again, which hopefully you won't. I mean, every year, with the exception of like, if everything goes into chaos like it did last spring, which I don't anticipate because we're already in chaos and we're adapting. But assuming we're kind of back to normal on a testing basis, rarely do I have, I mean, like the 2 years prior to Corona, I had 2 total people didn't pass. I think the year before that, I had maybe 3 that did. The year before that, I had 1. So normally everybody does. It's just you've got to, you just got to, yeah, I don't know. You just got to work a little bit. If you do it and you learn a lot, especially when we're reviewing, you'll be good. In fact, hopefully you won't just get a 3, hopefully you get a 4 or 5. I mean, I'm just looking around right now. I see more 5s than we've ever had in the history of APCALC this year. I saw it last year too, but I got screwed and everybody said, I'm out. And I just went home. But this year, I'm really, there's a ton of 5s and 4s out in this class and in the other one. Yeah.
How would the test taking work before quarantine?
What?
Quarantine.
I don't know. They gave multiple options last year. So
I was hoping it
I'm just gonna wait. I got an email about, make sure you give them a test at their home. I'm not doing that. It takes me 8 hours to make it. I'm not. I told them all, just take them and send them back.
Oh, yeah.
If they never come back, they're going to virtual and then out of the building.
If I take a little twist, I wouldn't have made it. So, you know,
I feel like the
How's that?
Oh, I think that's like
How you think?
Oh, yeah, yeah.